was forced to restrict its water supply in the early 1960s. This lasted from October 1961 to March 1965.
This shortage, along with many other droughts, prompted Japan to focus on increasing its fairly small storage capacity.
Currently, Tokyo gets 80% of its water from the Tonagawa River and the Arakawa rivers.
But what happens when those resources run out, and what feeds into them?
The Tone River, or the Tonagawa, is a major river of the Kanto Plain in Honshu, Japan. The river flows for 200 miles.
It is the most modified river in Japan.
The Tonagawa River is an indispensable source of water for irrigation. The Arakawa River is a Japanese drainage channel.
Tokyo normally enjoys plentiful rainfall, but the Japanese megacity could soon face water shortages. If Tokyo's rainfall is below average during a certain time period, then the city will experience the beginnings of a drought.
Now, every decade or so, Tokyo and its suburbs, which are home to more than 35 million people, experience a dry spell.
Tokyo has weathered a handful of particularly harsh droughts over the past century.
The Japanese government responded to this by expanding the city's water storage and turned rooftops into rainwater catchments.
Although the government made a huge effort, it may not be enough for a prolonged drought.
Most of the time, Tokyo relies on surface water, leaving very few alternatives for a major drought. One of the 2014 reports on urban water infrastructure listed Tokyo as the largest water-stressed city in the world.
Using the water gap method, the researchers were able to determine water stress.
The water gap method models a region's water cycle and consumptive water use for architecture, industry, and domestic purposes.
The Japanese government is helping Tokyo prepare for future water shortfalls.
One of the many innovative solutions involved engineering the 90,000 square foot roof of a local area so it channels the rainfall into a tank.
From that point on, the water is pumped into a stadium for non-potable use.
Cloud seeding, which involves shooting particles into clouds to reduce rainfall, is another tactic for boosting the city's water supply. This technique was successfully tested in 2013, however, many questions remain of its effectiveness. Our idea to help Tokyo is by transporting ice from the Arctic by tugboat.
Satellites could be used to locate icebergs that have already broken away from the ice sheet so that there is limited environmental impact. Icebergs that are roughly 100 million tons would be ideal even though they couldn't be moved by just tugboats. Therefore, using existing ocean currents would speed up the movement process. Before it reaches Tokyo, the big iceberg could be broken down into smaller, more manageable pieces, which could then be purified. Even though an estimated 30% of the iceberg would be lost during this movement, it would still be worth it. An iceberg this big could provide drinking water for about 5 million people, or roughly 15% of Tokyo's population for a year.